All right, gang, we're on to asymptotes, the very last part. Well, I thought I was ready to make the video. Okay, you've heard of asymptotes. I know in Algebra 1, I know in Algebra 2 you did it. So remember, this is what I'm going to remind you. If you have a horizontal asymptote, remember asymptotes, and anytime you're doing a horizontal line, it is the word hoi. Horizontal is the word hoi. It's y equals, and when you're doing an asymptote, we usually say it's y equals k. It equals some constant value. If you have a vertical asymptote, well, remember the word that goes with vertical is the word vux. Vux is x equal. Usually we say x equals h. H is just some value, some number that it's going to equal. When you have an asymptote, it's kind of like you're riding in the car and your brother or sister is playing the I'm not touching you game, and it's getting really, really close. But remember, you're like, I'm not touching you. I'm not touching you. Usually you get punched and, anyway, you get the idea. The idea of an asymptote is sometimes they can be a little bit of a jerk and you can never reach them as much as you want to punch the asymptote. You can't. So here's what we're going to do. If you have a horizontal asymptote and you're approaching this graph, and so I'm going to say as x approaches positive infinity. So I'm going to look at this right here. So as x approaches positive infinity, what is my asymptote doing? Well, it's either coming down this way or it's coming this way. So what I'm going to say is as x approaches positive infinity, the y value is going to get really, really close to whatever that asymptote's at. So your y value is going to approach that value that it's going to. I know that probably didn't make any sense. When we start writing it out, it will. But just remember this. Then you're going to have the reverse as x approaches negative infinity. So as x is coming in from this side. So as x is going towards the infinity line, your asymptote is going to, as your graph, it's going to come up and it's going to approach that asymptote. Whatever it happens to be, it's going to approach it. Here's what happens on a vertical, though. Horizontal asymptote kind of makes sense. When you look at it, you're kind of like, oh, okay, that somewhat makes sense. When we do a vertical asymptote, we have to approach from the positive side because remember, a vertical asymptote is going to go this way. So we're going to say as we approach from the right side towards this asymptote and as we approach from the left side, what's going to happen? Well, the asymptotes are either going to go up or the asymptotes are going to go down. What are they going to approach? Well, as they go up, they're going to go towards positive infinity. As they come in and they go down, they're going to go to negative infinity. So, as we're going to do it both ways, we're going to say as we approach the horizontal asymptote or the vertical asymptote from the right, the y value is either going to go to positive infinity or it's going to go to negative infinity. So again, it's either going to, as this is my vertical asymptote, as they approach, they're either going to go up or they're going to go down. That's the only options they have. So we're going to say the same thing. As we approach from the left side, y is going to either go up to positive infinity or it's going to go down to negative infinity. Okay. When you have a horizontal one, it makes a little more sense that it's either going to come up and go to positive infinity or it's going to come down and go to negative infinity, which is why this one is a little bit easier to look at. You're just always see, on this side, the y value is approaching the asymptote, and this way it's approaching that asymptote, whatever it is. Vertical, it changes. I'm hoping this makes sense. It either goes up or it goes down. I mean, it could go, let me see if I could do that. I don't know if I can. It could go the opposites. Y'all should try that. That's really hard to do. Anyway, it's not so much that you understand that. I just want you to have it for your notes. What's going to be important is that you understand this. When you have a function, exponential, whatever kind of function it is, the number that's on the end, this is the asymptote, this constant number on the end. When you have a fraction right here and you have this on the end, that's going to be my asymptote. So here's what we're going to do. we're going to go here. We're going to go y equals. We're going to clear that mess out. And we're going to do alpha y equals, and we're going to do 3 over x minus 1 plus 2. And we're just going to take a quick look at this graph. Okay, so you're looking at it and you're like, well, Sorry, I had to get a drink. Let me go to the table. Okay, I see there's an error. Something's happening at 1. What could possibly be happening at 1? Oh, wait. The denominator would be 0. 1 minus 1 is 0. You cannot have a number over 0 because it says no. That's undefined. That means when x is 1, when x right here is 1, I get some kind of error. So I'm going to draw my dotted line for my asymptote because my x value, my domain, it cannot be 1. So the other thing I'm noticing is not only is there an x equals 1, but it looks to me like there's a y issue. Can you figure out what that y value is? Well, this is the nice thing about your calculator for the horizontal anyway. You can kind of guess. It looks like it might be at 2. Let me go down here. That's 2 right there. What would happen if I put y equals 2 and graphed it? Oh, look at that. It gets really, really, really close, but it doesn't touch it. So that means at y equals 2, it looks like there's a horizontal asymptote. So I'm going to draw that here. So again, this was my horizontal, and this is what I looked at to get my vertical. Other than that, I'm going to graph it. So it's going to go like this, and it's going to go like this. Now, I know my intercepts are not right, and my pen is dying, but anyway, you get the idea. For example, consider the function defined here. We graphed it. Let's see if we can do it again. How many asymptotes are there on this function? Well, I can already see that if I take x minus 2 and set it equal to 0, I'm going to get at x equals 2. I don't even have to graph this. I know that at x equals 2, there is going to be an asymptote. Now, the other thing I'm learning is that this number on the end has something to do with my horizontal. This is at 1. This shifts the graph up 1. And so at y equals 1, I get another horizontal. So I'm going to go here. I'm going to say alpha y equals, and I'm going to say 2 over x minus 2 plus 1. I'm going to take that away. I'm going to graph this. Here it is. I know that at x equals 2, oh, look at that. At x equals 2, I get an error. But let me go here. I believe at y equals 1, because that 1 on the end, I'm going to graph it, and look, there it is, right there. So this goes this way, and it goes this way. It's a little harder to read with blue and blue, but you get the idea. All right, hopefully you're kind of getting the hang of this. Let's see if we can find the equation of the horizontal asymptotes of this. Horizontal is the word hoi. So that means I'm looking for the y equals 1s. Well, I know that there's going to be x1 at 2. The y1 is that not the same one we just did? Oh my gosh, it's the same one we just did. At y equals 1. Okay, so those two are the same. So the horizontal one is y equals 1. And if I was going to graph it, I'm just going to draw an arrow and say, is that one right there? Okay, there's that. Let's do the check for understanding.